This is the P6 Block 1 webinar to support the delivery of the new Glasgow City Council Numeracy and Mathematics Progression Framework. If you haven't already done so, please join the Microsoft team, where you will find all documentation related to the progression framework and also find folders where you can collaborate with your colleagues. So in implementing a new set of documentation, let me outline what is staying the same or will be familiar to you and what's new with the progression planners. In terms of what's the same, you will still find the content covered by each primary stage displayed in an annual overview. Research and best practice hasn't changed, so we're still advocating concrete, pictorial, and then abstract approaches to introducing new concepts. And that's right through the school, so if we're introducing decimals for the first time, then we need concrete examples for that before moving on to pictorial and more abstract methods. Problem solving should still be at the heart of all your teaching, providing lots of real-life context for our pupils so that they understand the purpose of learning the mathematics we're presenting them with. We'll still have high expectations of fluency with mental strategies, so all of the work around number talks and retrieval practice will still be essential. These progression planners are still based on the Curriculum for Excellence, although during the time frame of this implementation, we will have a new curriculum coming out from Education Scotland. So whilst there will be changes over the course of the next couple of years, at present, the resources that you are familiar with and have in school to support the delivery of mathematics, whether that's textbooks or online curricula, they will all still be relevant and useful to you in delivering the teaching points on these planners. So in terms of what's new then, effectively we have a new technical layout. We have 6 blocks of teaching. Each block should be taught for a period of around 6 weeks. And the core number concepts that we visit in each of these 6 weeks will be built on in bite-sized steps. So core calculation and core number concepts that are central to the understanding of our number system will appear in every one of the 6 teaching blocks. There will be end-of-block assessments available for you to use if you wish. Alongside the annual overview planner, you will find 6 medium-term planners, one for each block within Primary 6, and similarly 6 medium-term planners structured in that way for the other year groups too. These medium-term planners offer suggested learning intentions and demonstrate how you might cover the content over the course of 6 weeks. What is also new in our progression framework is more direction in terms of the age and stage appropriate calculation strategies that we would hope learners were moving on to as they move through the primary stages. That's in terms of things like when to introduce column addition and subtraction, when to start moving away from methods that have multiple steps like grid method, because ultimately we want our pupils to move on to the most efficient methods so that as they move into secondary, we're freeing up that working memory and making sure that they are increasing their speed in terms of calculation so that as they get to timed SQA examinations, they have the best possible chance of success. And to that end also, you will find in these progression planners more direction in terms of which number facts the pupils should be able to recall at each primary stage. So that covers things like number bonds, doubles, and moving on to times tables and division facts. So the annual overviews look a little bit like this. Hopefully you'll have the PDF version in front of you also, but just to indicate the structure of the overview, You can see at the top there is the year group the annual overview is relating to and which curriculum for excellence level it is in line with. At the top of each block, you've got the months of the calendar year in which you should be aiming to deliver these blocks of teaching. Down the left-hand side, you'll be familiar with these organisers from our previous trackers. These are relating to the areas of the maths curriculum that the teaching points are under. And then the blocks of teaching are running vertically along the page there. So the part that's highlighted in blue is showing you block 2. And as we said, there are 6 blocks of 6 weeks across the school year. This is to facilitate revisiting concepts more frequently so that retrieval's built into your planning and we don't get a situation where pupils perhaps haven't spoken about or been exposed to work around fractions since term 2, the previous session. In terms of the block overviews then, you've got pages like this where the core teaching points are sitting in the central column. So this yellow header is showing you the block teaching points. And then before that and after that, you've got teaching points that come before the core learning in the progression under support. So this is the step before the on-track teaching that we're looking at. And then we've got some teaching points suggested to provide additional challenge to those learners who are ahead of track. It's worth saying that these are mini progressions. So I would say that the support column here is really what you need for your just off track learners. And as we have had for many years now, if you have pupils in your class who are working at a developmental level that is further behind that in the progression, you will need to look at a different year group planner in order to find the appropriate teaching points for those learners. Alongside the medium-term plan, you've got some suggested learning intentions, and this is really to demonstrate the sort of pace of moving through concepts that is necessary to cover the block in 6 weeks. So the main departure really is that rather than spending perhaps a whole week or more on, say, addition, we may only spend a couple of lessons looking at addition in a given block and then be moving on to subtraction and moving on and moving on, but in the knowledge that we're going to be coming back to addition in 6 weeks' time. The weekly learning intentions have been structured to reflect common practice, whereby teachers tend to teach core number concepts alongside wider maths topics. And we're aware that many job share partnerships effectively divide the labour in that way too. So each week of that suggested progression, you've got some of the beyond number topics mentioned as well as the core number. The other reason for providing example learning intentions is to support early career teachers or those that have moved stages in terms of making the learning intentions child-friendly, and to remind us that the specifics of learning activities might appear in your success criteria but shouldn't be in your learning intention, because we want them to be one learning intention for the whole class to participate in, and that's good for inclusive practice as well. So something as straightforward as we are learning to divide will cover everybody in the class, even if we've got some pupils working with a low number of concrete materials that they are physically sharing out, and others working on quite complex division strategies. So for the rest of the webinar, I'm going to run through the teaching points for Primary 6 Block 1. I'm going to be running through the block by organiser, but as ever, you will find in your planning, for your weekly planning, for your lessons, that Many of these teaching points hang together. The best example really is this first organizer, where we're looking at core number system knowledge. The counting, ordering and making of numbers up to 100,000 will also come into lessons around calculation. So although we may do distinct lessons on each teaching point, it's more likely that more than one will be visited as we go along, or certainly that within a sequence of a few lessons we'll be using these skills more than once. Hopefully that will become clear as we talk through. So in terms of the core number system, we are extending our skills around counting, ordering and creating representations of numbers. We're moving that on to numbers up to 100,000. So in primary 5 we've extended up to 10,000. By the end of first level we had them comfortable with numbers up to 1,000. So as we're moving up through the second level stages, we are increasing the order of the numbers we're working with, but revisiting a lot of the skills, all of the skills that we've learned so far in earlier primary stages. Partitioning numbers to 100,000 and being able to do that in different ways to support our calculation strategies. We're doing lots of work around estimation, and in terms of that number fact recall, we want them to be able to recall number bonds to 100 in a very fluent manner, and be working on multiplication and division facts to 10 times 10. So just a reminder of those visuals, those concrete or pictorial examples that can support the extension of our pupils' awareness of the number system right up to 100,000. So using place value counters or digital versions of that really helps them to understand that link between a digit, its place and its value, and place value charts will also support with that. We need to make sure that we don't assume that they will be fine with extending into another column. We need to do lots of practice and lots of counting in the same way as we would when we were introducing two-digit numbers. In terms of the partitioning, yes, we want them to be able to partition by the columns in the way that the visuals show. But if you look at the handwritten example at the bottom left, we also want them to be able to partition in different ways in order to support mental agility with calculations. So the second example, where the 50,725 has been split into 50,000, 500, 100, 125, is an example where somebody has done that because they're about to look at multiples of 5. If you wanted to divide 50,725 by 5, that's the sort of partitioning that would support you with that. So depending on what they want to do with a number, it's important that they've got the facility of splitting up a number in different ways that help them. In terms of positioning on number lines, it's getting a bit unwieldy to work with numbers of this order, but it is still possible, and it's worth revisiting these skills so that pupils are able to apply their knowledge to bigger numbers. So as we've visited through primary 3, 4 and 5, in terms of estimating the position of numbers on a number line, the process is exactly the same. So they're looking at the range of the section of the number line that they're presented with, finding any midpoints or marking on midpoints if they need them, looking at the increments they've got and what they stand for, and having to subdivide those increments if necessary. So if I were wanting to mark 31,200 onto that first number line, I would be looking at 31,000 and 32,000, probably marking on 31,500 so that I could see the middle bit, and then estimating where exactly 31,200 might be. The screenshot at the bottom left is a really nice manipulable online tool that gives practice with that. So it might be worth exploring. Ultimately, we're trying to give them the skills so that if they have a very open-ended problem or practical example, something like the little cartoon character is holding the very blank number line, they've got some strategies to do it. So if they were looking at that blank number line marked only at its ends, 0 and 1000, then we should be building them up so they have strategies to mark the midpoint of that with 500, marking any other increments. So could they then subdivide again into 250, 500, 750, and so on. We want to give them the confidence of that mental number line so that they can use it to help them with things like measure as well. Moving on then, in terms of estimating, the skills by this point are that they can estimate an answer to a question by rounding. So by doing this, we know that pupils can find an approximate answer to a calculation, and that helps them to know what they're expecting. So as in the first line that's typed there, 3,543 plus 12,456, if a pupil rounds those quickly to their nearest thousands, they know that they're going to be expecting an answer around 16,000. So in the handwritten example on the right-hand side there, if they then badly align their columns when they do column addition and end up with an answer that's 47,886, we know that they can then check themselves and say, oh, hang on, that doesn't seem right. Let me look again. And they can check the reasonableness of that answer. And so that estimating for calculation is something they can do across all 4 operations as shown there. And it's a really good skill to have as part of your calculation lessons, which I'll come on to in the next section. And with this particular teaching point, there's good options for linking to any budgeting or enterprise work that you're doing as well. We learn to estimate because it helps us problem solve for things to do with budgeting. One example there, if we're going to be making multiple batches of a recipe, we need to have a look at what the totals will be and whether we can buy particular items from the supermarket or whether we're going to need multiple of those items or a bigger unit. Okay, so if we were using that brownie recipe and we know we've got to make 4 batches of it, we could quite quickly estimate whether we're going to have enough of each ingredient. Okay, so in terms of this number fact recall, we've worked up from primary 1, looking at number bonds to 10, extended those to number bonds to 20, so making that link of, well, I know 9 add 1 is 10, so 19 add 1 must be 20. Extending that up to finding the next 10, so being able to find those friendly numbers on number lines. And then from primary 5, we were looking at number bonds to 100. And the example written on the open number line there was the same one given in the primary 5 webinar, because actually what we want to happen by the end of primary is that they've internalized this idea. We want to have that internal open number line so that when they're trying to jump up to the next 100 or apply that to thousands or whatever else, they know they can jump to the next 10 and then make up to the whole 100. And that will avoid that very common problem of a child trying to make 100 and telling you it's 69, add 41, because they're wanting both columns to make up to 10. Okay, if we internalize the number line version, they're much less likely to make that problem because they're saying to themselves, well, 1 takes me to 70, and then I know it's 30 to get up to the 100. In terms of multiplication and division facts, we are aiming for our primary 7s to be fluent with multiplication tables to 10 times 10. And this is really to free up that working memory so that as they move into secondary and are faced with more complex problems, they're not held up by having to count up the stations to find every multiplication that they require. We do still want to ensure their conceptual understanding of tables as being repeated additions. We want them to recognize patterns, and we want them to understand that relationship between the stations, so 5 times a multiple being half of the 10 times, 9 times being the one before 10 times, and so on. That's really crucial, because if you were to ask me what 9 times 600 is, I would quite quickly be able to work out that 10 times 600 is 6,000, and then I'm going to take off one lot of 600. So I can work out quickly that it's 5,400, and that's with much bigger numbers because I'm understanding the idea, the relationship between those stations. So all of that is still really valid. However, having good quick recall of the basic tables to 10 times 10 can set them in really good stead for column multiplication, which is the most efficient method for multiplying much bigger numbers. And we can do that through chanting, through frequent recall practice, through an expectation that they should be trying to learn these. And yes, some children will find it harder. However, if they can get a good number of them off by heart, that's really going to help them. We do also always still want to avoid that very public shaming type practice where we're pitting pupil against pupil. Please still do avoid that. We're in a world now where we've got lots of options for individualized practice. So you may still have SumDog available to you in school. There are lots of games out there like Hit the Button. And if you're part of the Magma Maths implementation, then you will find as you get more familiar with that platform that there's lots of practice opportunities there as well. It should be an individual pursuit in that sense, that we want the children to be trying to improve their own skills around that and not necessarily being worried about how they compare to somebody else in the class. So moving on to the next organizer in the block, addition and subtraction. We have 4 teaching points here. Adding and subtracting up to 5-digit whole numbers with bridging using any strategy. So in our progression planners, we have introduced column addition and subtraction from as early as primary 3, not including any bridging at that stage. Then in primary 4 and primary 5, we have introduced bridging. So this, in that sense, for future cohorts, this is a revision point and an extension to 5 digits, but the process will be familiar to them. We are going to apply that to one-step word problems. We're going to be using rounding to estimate our answers and being able to use the inverse to check the calculation as well. So although that sounds like an awful lot, these steps can be covered within a couple of lessons because they are all necessary to solve problems. So to that end, I've grouped these 3 teaching points to demonstrate that these could be all taught within the same lesson. So if we're being asked to add 56,521 plus 8,204, the first thing we can train the pupils into systematically doing is ask themselves the question, what answer am I expecting? So we're rounding to the nearest 1,000, 57,000 and 8,000 is going to be about 65,000. So that is a quick first step that is repeating our estimation skills. We would then go ahead and complete the calculation. Now there's 2 options offered there for you. One is a partitioning strategy, and that's totally valid. The other is an efficient column algorithm. So at this point then, they would be asking themselves, does that seem right? And looking back at that estimate they made, 64,725, if I rounded that, it would be 65,000. So that does seem right to me. And then let me double check. You're going to do the inverse, and in this case, this person's chosen to do that on an open number line. I'm going to do the inverse operation to check that my answer is correct. Okay, so in this case, they've started at 64,725 and taken away, subtracted the 8,204 in 3 jumps. Equally, they could do the column method to check their answer as well. So you can see that if you model and expect that sequence of estimating, then working it out, then doing the inverse to check, we're covering a whole load of skills there in one sequence. And yes, there's lots of bits where they might go wrong, but then we can pick that up and fix the teaching of that particular area. In terms of word problems, for numbers up to 100,000, really we can look at any source for these. It's to provide context and purpose for learning how to calculate. So when you are looking for resources in terms of worded problems, it's just important to interrogate the source or the resource that you're using in terms of the order of the numbers. So in this block, whole numbers up to 100,000. So you want to be looking for word problems where we've got numbers with 4 or 5 digits, so that we're practicing the order of calculation that is age and stage appropriate. The number of steps, so in this block we're only interested in one-step word problems. We want to just have to do one calculation to get our answer. And then you may want to interrogate for other concerns, so accessibility of the language for learners with EAL, representation of different cultural considerations like names and so on. And in terms of language, you may want to explore Magma, which has not only many libraries of word problems, but also has translation facility, so that you wouldn't have a literacy barrier to this teaching point, because ultimately we're interested in their mathematical understanding, their conceptual understanding, not in their reading ability. So again, in terms of that accessibility, consider whether actually it's reading capacity that is a problem rather than the comprehension. So if there are children for whom the actual physical act of decoding and reading the language is a problem, then you should try to read the questions to those children so that they can demonstrate their maths understanding. Okay, moving down the block again then to multiplication and division. We are going to be using our mental agility to multiply and divide numbers with multiples of 100. So there's some examples given there, because this is really using our times tables knowledge and our division factor knowledge to be able to deal with multiples of 100. So 5 times 300, we want to link that to what we know about 5 times 3. We are going to introduce column multiplication, including exchanging. And we're going to be using short division to divide numbers up to 99,999 by 1 digit. Okay, and including remainders. So in terms of that mental agility and that number system understanding, we're going to be looking at things like 5 times 300 and potentially modelling that for them, but looking at what we know about 5 times 3. So 5 times 3 is 15. We can show them that it's 15 if you want. There's 3, 5 lots of 3, that's 15. In the same way, we can model 5 times 300. And place value counter is really helpful for this because you still have the similar number of things on the table. Here's 300s. If we make that 5 times, 5 groups of 300, we can count those up and find that it's 1500. And yes, they will probably tell you that you are adding 2 zeros, but actually we're using the place value to support the link between single digits and related higher numbers of digits. And if you wanted to make the interim link, you could model through 5 times 30 as well. Okay, so that idea of number strings and related calculations is very helpful for agility, mental agility with multiplication and division. Okay, in terms of column multiplication, we're going to be multiplying whole numbers by 1 digit. All right, so we'll start with an example of linking to the distributive law. So if we look at 24 times 6, that should be read as 20 times 6 and 4 times 6. Okay, so we can model that through, and in previous year groups we've worked with grid method and area models of this type. 6 times 20 and 6 times 4 gives us 120 and 24 to add together. And this gives us an answer of 144. So extending that then to a higher number of digits. So here we've got 342 times 7. Pupils should be confident splitting that up, partitioning that number in the same way into 340 and 2, and tackling each of those individually. And what we want to do at primary 6 is to relate that to column multiplication in the following way. So you would be saying to them, okay, so 342 times 7, so we've got 2 times 7. 2 times 7 is 14. So because that is beyond 10, we're making an exchange there. So our 4 units sits in the units column of our answer, but the 10 of the 14 needs to sit in the tens column. Then we're thinking to ourselves, right, it's 40 times 7, so 4 sevens is 28. We've got to add in that 10 that we made with the units, so 29. So we're going to put the 9 in our tens column, and the 2 represents 200, so it's exchanged and brought across to the hundreds column. And then finally 300s, 3 times 7 is 21, and then we've got the 2 that we brought across, that makes 23, and there's our answer, 2,394. So we want to make links with the distributive law to show them that that's what's happening in the column method as well. We still do, when we're doing that column algorithm, we are thinking 2 times 7 and 40 times 7 and 300 times 7. And it's just a short way of doing the adding up at the same time. Whereas with our grid method, we're having to do an addition calculation at the end. In the same way, we want to provide a link to partitioning when we're using short division as well. So the short method for division should be laid out as shown on the screen there. 84 divided by 5, because we're interested in remainders here. So we want to provide them with questions that produce a remainder. So if we were to model this through with place value counters, and here what we've done is partition the number into 80 and 4. We're dividing by 5, sharing out that number into 5 pieces. So we're going to divvy up as many 10s as we can first. Okay, and that is the same as us looking at the 80 in our short method, how many 5s can we make into 80? Well, it's 10, so we're going to put 1 10 in each of our sharing boxes there. We've then got 3 10s remaining, and so those need to be exchanged and added to our 1s. And that means we've now got 34 1s to share out. And if we do that very efficiently, we'll find that we managed to give 6 into each of the sharing boxes. And we were left with 4, so remainder 4. And as we move through the blocks, we'll talk about what to do with that remainder and how to express it as a fraction and as a decimal. But just now, we're happy with that being left over, the remainder. So for our final core number topic, we've got fractions, decimals, and percentages. These number topics come back every single block. So we will be talking about fractions 6 times across the year for a short amount of time, rather than a block of fractions for 2-3 weeks in term 3. So we're going to use our multiplication and division strategies, our knowledge, to find a fraction of a quantity. And in primary 5, we just did this with unitary fractions, where the numerator is 1. But now in primary 6, we're moving on to where the numerator may be more than 1, 2. And we're also going to make fraction links to angles and compass points during our shape lessons. So I'm going to talk about that when we talk about shape. In terms of this single teaching point then for fractions, we want to remind our pupils about what a fraction is talking about when it's written in that way. So if we provide them with a visual, pizzas are always really helpful, but it could be chocolate bars, whatever you like. 1/3 of that pizza looks like this. And it's because the top number's telling us the number of parts that we're interested in. So if I ask you to take 1/3, you're going to take one of them. And the bottom number's telling us how many pieces altogether there were in that pizza, or how many pieces the whole has been split into. All right, so we need to remind them of that notation and be sure that they're fine with that. And once they're fine with that, we can move on to finding fractions of quantities. All right, now visuals are really helpful as well. So if you've been talking about pizzas, maybe draw a sharing circle that is based on that pizza shape. If we take 21 cubes at this point and share them out between the thirds, we can quite easily come to the conclusion that 1/3 of 21 is 7, because we've managed to share out those 21 into 3 equal groups, and each group is 7 cubes. So 1/3 of 21 is 7, and when we've done all that work with concrete or pictorial examples to provide this shared out example, we should also talk about, therefore, 2/3 of 21 is 1/3 and another third together. So 2/3 of 21 is 14. And we can also talk about the fact that the whole is 21 as well. So 3/3 is 21. We could also use place value counters for this in a sharing capacity. So this is related to bar models and so on. So our whole, the whole we're talking about is 65 here. We've got to share it out into 5 pieces. Okay, we're going to share it into 5 pieces. So 10 in each. Then we've got to make an exchange here. So we're splitting up our 10 into 10 ones, and we'll share those out as well. Now we've got our 65 shared into 5 groups. So we are interested in 2 of those groups. The top number is telling us how many groups we're interested in. So here's 1/5 is 13, but we want to know 2/5. 2/5 of 65 is 26. All right, so using these, as I said at the beginning, concrete pictorial and then abstract approaches need to be used right through the school when more difficult concepts are being introduced. So even though your pupils might not need place value counters for addition, they may well need them for working with fractions. Okay, last example, bar model version this time. If the whole is 21, they may be familiar enough with their times tables knowledge to understand, well, if I've split 21 into 3/3, what I'm wanting to find out here is 3 times what makes 21. And if they've got that times tables knowledge, they may start to be able to tell you in an abstract fashion that 3 groups of 7 makes 21. So 1/3 of 21 is 7, 2/3 is 14. All right, so any of these visuals will really support that conceptual understanding. Okay, for the rest of the block, we've got 2 Beyond Number topics available to us, mandated to us, I should say. So we've got teaching points within shape and space. This organizer comes back in block 4 of the progression. And then we have some teaching points around information handling, which appears 4 times across the year in 4 different blocks. So in terms of shape and space, we are building on knowledge that we have developed in primary 5 in terms of comparing angles to right angles. And now we're adding in the vocabulary of that. So before in primary 5, we were just talking about if an angle was less than a right angle or more than a right angle. Now we're learning the mathematical terminology for that, acute being less than 90 degrees, obtuse being greater than 90 degrees, and then introducing the idea of reflex angles as well. They need to understand how those terms relate to a right angle and how they relate to a straight line. Okay, it's a couple of really nice online tools that you can have a look at there, but equally worksheets of the style that you can see a screenshot of, perfectly valid for this type of skill. In terms of shape and 2D shapes, we've built up through the early stages a good foundational knowledge in terms of polygons and their names. We've learned about regular, meaning all sides the same length and all angles equal. We've learned that irregular shapes, irregular polygons, have the same names, but they are an irregular version of that. So a 6-sided shape with all different lengths of sides is still called a hexagon. And actually within symmetry, we've talked about regular shapes having the same number of lines of symmetry as their sides and corners. But it's important to point out that irregular polygons may also have lines of symmetry. They may not, but if we look at the 10-sided irregular decagon there, that looks like it probably has a line of symmetry vertically down the middle through the right angle that's in it, and equally across horizontally. But it isn't necessarily the case, depends on the shape. There's lots of possibilities, of course, through Expressive Arts IDL to revise and revisit understanding of criteria of 2D shapes and looking at design principles and aesthetics and the importance of things like symmetry to architecture. Our other teaching point for shape and space is use of the 8 compass points and angles to give 3-figure bearings, and this is the new bit of information. So we've met the 8 compass points in primary 5. We've learned about how we can talk about turns in terms of angles, so a quarter turn being 90 degrees, a half turn being 180 degrees. We've also laid onto that the distance between, say, north and northeast as 45 degrees. But the idea of a 3-figure bearing is new. So 3-figure bearings are a very technical way of measuring a direction. So they're always measured clockwise from north. So that plane there in the example is flying on a bearing of 30 degrees. Okay, so just a very specific little bit of knowledge. And the other thing to say is that if the angle is less than 100, we should use a 0 as a placeholder. So the bearing always should be expressed as 3 digits. So actually, in this case, the plane is flying on a bearing of 030 degrees, or it should be written in that way anyway, a 30-degree bearing. Good, right, last teaching point for this primary stage. Interpret bar charts, pictograms and line graphs with different scales and keys, including reading unlabeled midpoints. Okay, so the example given there is if your axis is labeled 2, 4, 6 and so on, then they should be able to deduce where a value is 3, and isn't appearing on the axis. All right. So a couple of examples here of the types of information that you might want to present them with. Relevant information is always good, and with line graphs we want to start building that possibility of children kind of telling the story of what's going on in the graph. So there's some examples of questioning in the blue box there. All the basics, how many children surveyed said they would go out in the rain. I'm just reading a single data point like that. On that bar chart there, the yes bar is going up to an unmarked midpoint, an unlabeled midpoint. So they should be able to read that as 19, even though there's no line across the axis, and even though the axis doesn't have 19 written on it. They should have built up that knowledge through primary 4 and 5. How many were asked altogether? So looking at multiple data points as well. And then with the line graph, things like how long did it take Jamie to get to his destination? How far did he travel? And then particularly the last one, I think, is where we're moving knowledge on in primary 6. Look at how far Jamie travelled in the first hour of his journey and the second hour of his journey. What do you think might have been happening? And so you can have those discussions about what the traffic might have been like and so on. So actually getting into what is this graph telling me about the situation? And on that point, really I just wanted to draw attention to the links with literacy that data handling requires. So in the literacy curriculum documents, we do see graphs and timetables appearing under examples of texts. These are a type of text that we have to be familiar with and literate with. So it's really important to expose our pupils to lots of different layouts and infographics and so on. You might want to consider goal-free problems as part of your teaching. That's nothing out of the ordinary, really. It's just the idea of showing a stimulus that is a set of information, and rather than having directed questions around it, actually just asking the pupils what they can tell you about the information presented. Goal-free problems is something you can find lots of blogs and things about on the internet. Education Scotland have promoted it in the last couple of years at maths conferences and things. It's just a really nice inclusive way of getting the whole class interested in some information. And there's some good websites out there with interesting infographics for kids and so on that you could use as starter activities, or quick number talk after lunchtime or whatever. Okay, that's us got through the walkthrough of all the teaching points. There's a QR code here for you to log any feedback you have either about this webinar or about the planning documents in general. Please do provide feedback. It's anonymous, or if you have a question and you want us to get back to you, then there's a place for you to leave your name and email if you'd like that. As I said, there are end of block assessments in development, and there'll be more information communicated about those the other side of the summer holidays. And then there will be Block 2 webinars taking place in the same way as these Block 1 walkthroughs have happened. So reminder that all information and documentation is housed on the Microsoft team. You can get support from me, Shirley-Ann Brightman, and like I say, we do welcome your feedback. It's absolutely crucial to improving and getting these planners right for the longer term. Just at the very end, and I'll come back to this slide afterwards, but at the end you've got a slide of useful links. These are to anything I've referred to in the presentation. And there's a MathSpot placemat with QR codes that take the pupils directly to the various manipulatives. So if you've got iPads in class and you just want an easy way for them to get onto Dean's materials or place value counters, then you might find these useful as sort of laminated placemats on your class tables. Thanks ever so much for listening, and keep in touch. Hope that it's been a useful session.